Welcome to the Number Play game show. Look at these 7 contestants lined up on stage. They aren't going to solve a standard math equation today. Instead, they are playing a game with a strict logical rule. Each person must call out the exact number of children standing in front of them who are taller than they are. Let's test this rule on our diagram. The child at the very front looks forward. With nobody ahead, their answer is 0. Moving to the second child, we draw a line forward. May see one taller person ahead, giving them a 1. The third child looks forward. We ignore everyone behind them. Seeing 2 people in front, but neither taller, they also get a 0. Scanning the rest of the lineup front to back, we generate the complete positional sequence. 0, 1, 0, 2, 2, 2, 1. A 0 here doesn't mean a person is the tallest in the whole group. It simply means nobody in front of them is taller. We are mapping hidden structures without ever measuring exact heights. Let's head to the factory floor to explore parity. Parity describes whether a whole number is even or odd. This diagram shows how parity works physically. When we sort these blue blocks, the even numbers always lock together into perfectly matched pairs without anything left over. Odd numbers will always leave exactly one single unmarked block hanging off the top. Adding 2 even numbers just stacks neat pairs on top of neat pairs, giving us an even result. But when we combine 2 odd numbers, those 2 lonely blocks find each other and lock together to form a brand new pair. That proves an odd plus an odd always equals an even. If we add an even stack to an odd stack, that single extra block is left hanging out alone at the top. An even plus an odd is always odd. By tracking these blocks, we can predict whether an addition sum will be even or odd before we ever calculate the specific numbers. Look at Kishor's puzzle booth. He has 5 empty boxes and a deck of cards containing only odd numbers. He is trying to pick 5 cards that add up to a target of 30, and he is swapping cards endlessly. We can run a parity proof on this equation to test his goal. Adding his first 2 odd cards together gives us an even sum. Taking that even sum and adding the 3rd odd card makes it odd. When we finish the process for the 4th and 5th cards, the sum of 5 odd numbers results to an odd number. Kishor's target of 30 is an even number. Since an odd total cannot equal an even target, his puzzle is mathematically impossible. Let's test another textbook problem. 2 siblings, Martin and Maria, were born exactly 1 year apart. Today, Maria claims the sum of their ages is exactly 112. Pause the video and look at this equation. Based on the rules of parity for consecutive numbers, is Maria's claim mathematically possible? Because they were born 1 year apart, their ages are consecutive numbers. In any consecutive pair, one is always even and the other is always odd. We know an even plus an odd must result in an odd sum, so their ages cannot equal 112. Parity acts as a logical filter. It saves you from testing endless combinations by instantly identifying impossible parameters. Let's head back to the main stage for a final coin bank challenge straight from your textbook exercises. This equation breaks down Lakba's piggy bank. He has an odd number of 1 rupee coins, an odd number of 5 rupee coins, and an even number of 10 rupee coins. He claims the total value is 205 rupees. Use your parity addition rules to determine if Lakba's total is possible. Work through the odd and even coin values and drop your answer along with your reasoning in the comments below. As a quick review, this cheat sheet shows the core arithmetic rules we proved today. Odd plus odd equals even. Even plus even is even, and even plus odd is always odd. Mastering these logical patterns gives you the analytical tools you need for number play. We will apply these exact rules to grid matrices in episode